So now I'll explain how to draw a SRM geometry in magnet. So first and foremost thing, you set the units. You set the units to millimeters. Then you can have tools, keyboard input bar. We are going to give the input in keyboard, and we can set this as r comma theta. So this you can set this as r comma theta. So the first thing that we can do is we can first draw the shaft. So for this I am sharing you this PPT, and these are all the dimensions of this particular machine. So this is the machine that we are going to simulate. So first we'll take up the shaft. We'll draw the shaft. Shaft is of radius 4.25 millimeters. So we'll draw a circle because shaft represents as a circle. So we'll take it as a circle. So I'll draw a circle here. The center is 0, 0. The radius is 4.25, 0. I'll draw a circle. So the first part is over. Now then we'll draw the rotor part. So to draw the rotor part, I have given the calculations here. So what is given? The bore diameter is given as 24 millimeters. So what we can do is we need to draw an arc, and they have given pole arc as 24 degrees. So we'll take this as reference, and this will be 90 degrees because we are plotting in r comma theta plane. And then what we can do is we are taking this as 90 degrees, and since it is 24 degrees, we will take 12 degrees this side and 12 degrees this side. So this will be 90 plus 12. This will be 90. This will be plus 90 plus 12. This will be 90 minus 12. So first we are going to draw an arc from 24, 78 to 24, 102. If you see the difference, this will be 24, right? And then once you do that, we know HR. What is HR? Height of the rotor pole. The height of the rotor pole is given. And to have a straight line, we need to do a small calculation. So for that, I have given this particular calculation. So it is 15, 109.43, 15, 70.56. So this is what we are going to do. Now we'll see this. I'll just draw this in magnet. So I'll come to the magnet window. I'll select arc. The center point is 0, 0. The start point is 24, 78. The end point is 24, 102. So if you see view all, I'll get an arc. Okay, I'll get an arc. Right? So now I need to draw a line here. So to draw a line, I'll use this. 24, 102 is the start point. To 15, what is the point? I'll just go back to that particular point. 109.43. 15, 109.43. So I'll draw this. Okay. And then here I need to draw another line. So to draw another line, I'll take the coordinates. So what are the coordinates? So the coordinates are 15, 70.56 to 24, 78. Okay. So 15, the second point, 70.56 to 24, 78. So I have drawn this. Okay. Now what I need to do is I need to rotate this because I have 6 poles. It's a 8x6 machine. So I need to have 6 poles. So I'll select this, draw, I'll say rotate edges. I'll give the rotation angle as 60 degrees. Okay. And I'll say you make number of copies as 6. Right? So 6 into 60 is 360 degrees. So I'll say apply. Okay. So I have 6. So I have 6 poles. Now I need to join these poles. I know this particular point, it is 15. So first I'll put a circle and I'll show how to segment the edges. So I'll say 15 comma 0. So first I'll draw a circle. So I have drawn a circle. So after I draw a circle, I need to remove the unwanted portions. To remove the unwanted portions, I'll select this and I'll say draw segment edges. So when I say segment edges, it will be splitted and I can delete the unrequired portions. Again, I'll select this, draw segment edges. So this portion I'll delete. So now I have a SRM rotor structure. So when you say view wall, I have a SRM rotor structure. Now in the similar way, we can go for a stator structure. So to have a stator structure, I should include the air gap. So when you see this, I have included this air gap. So what is that? 24.5. Again, the same procedure. The pole arc is 21 degrees. So I split it and I get this. So I'll first draw an arc. So from 0, 0 to 24.5, 79.5 to 24.5, 100.5. So 0, 0, I'll select this arc 0, 0, 24.5, 79.5, 24.5, 100.5. So I have drawn this. Now I should draw a line. So what is the starting point? 24.5, 100.5. What is the end point? 34, 97.5. So this is the start point. 34, 97 point. I'll just check it. 5. 97.5. So I have drawn this. What is the next point? The next point is 34, 82.45. 34, 82.45 to every time you press a line, after that you press a escape. Okay. And then 24.5, 79.5. Okay. So from this, okay, to 34, 82 point, I'll just check it. 82.45. Okay, see, now I have got this. I have got this. So you just draw a line. Now what we can do is we can rotate the edges. We can rotate this. Draw, rotate it. It's not segment edges, draw, rotate edges. Okay. So I'll just select it, draw, rotate. So I need 8 stator poles. So I'll have 45. Okay, and I'll say 8. Okay. So 8 poles, 360 by 8 is 45. Now I'll say apply. So I have 8 poles. Now I should join this. A similar way, what we can do is I can draw a circle. So I'll just draw a circle. 0, 0, 34, 0. And now the same thing. I'll select this. I'll just delete this. Okay, unknowingly it has come. I'll select this. I'll say draw segment edges. So now I'll remove the unwanted portions. Again, the lower half, draw segment edges. I'll remove this. Now I should complete this. So that is why your back iron thickness is given. So the back iron thickness is 11.25. So I should add 34 and I'll add this back iron thickness. 34 plus 11.25. 34 plus 11.25. So 34 plus 11.25. Okay, I think 34 plus 11.25. So 34 plus 11.25 will be 45.25. It will be 45.25. So with this, I can complete it. Okay. 45.25. So I'll draw a circle. So see here, if you see this, now the design is complete. So I have a stator, I have a rotor. Now in any thing, any machine design, I need to have a outer geometry. For that outer geometry, what I'll do is I'll select a circle. I enlarge it with a circle of air. I'll put this as 60, 0. So this is the geometry. Now I should apply materials to it. So to apply materials to it, I'll select this part. First I'll select shaft, model, make a component line, shaft, and then I'll say cold roll steel. This I'll take it as 60 millimeters. I'll select the rotor, model, make a component end line, cold roll steel as it is. I'll keep the same steel. Model, make a component end line. Okay, okay. This model, make a component end line. This is, I say, outer air, and I'll make this as air. Similarly, inside, here one point you please understand. Since we might rotate the rotor segment, I'll click this, ignore holes. I'll call this as inner air. I'll call this as inner air. So now if you rotate it and see, say I have got a SRM model. So this is your switch reluctance motor model. So one more thing is pending. What is that it is pending is? So here I need to give the coil. So for giving the coil, I'll create a line. Okay. And then so this unwanted portion, as the same way, I'll delete it. Model, draw segment edges. This unwanted portions. I delete this. Now what I'll do is I'll select this and I'll say model, draw mirror edges. So when I say this, what will happen? It will get the edges here as well. Now I can select both these things and I'll rotate it by 180 degrees so that I'll get it in the opposite side, because in an SR machine, these two are called as A phase. I'll call this as, these two are A phase, this is B phase, C phase, and D phase. This is a 4-phase machine. So I have created a model. So now I need to provide the excitation. I need to provide the excitation. For that, I need to make it as a coil. So I'll say model, make a component line, C1. I'll make this as copper. The same thing here, model, copper. I'll make this C2, model, C3, model, C4. Okay, so now I'll select all these things. C1, I'll press shift, I'll select, go to here, make simple coil. You press all these things with the shift button, okay, and make model, make a simple coil. So here you can give the properties. So the number of turns, what they have mentioned is 316 turns, and it's current driven. and we can give the waveform here, magnitude 4.5 amperes. Okay, so this is the basic model. You can also make this as large, but in simulation it does not matter much, but you can also again make it bigger. Okay, this coil size. So now what you can do is set solver options. You can go for non-linear. Source frequency you can set it as 50. Okay, and then you can say this is static, because what do you mean by static is machine will not be moving. Machine is only in this particular condition. So I'll say solve static 2D. So you'll get the value of force, so you'll get the value of flux linkage. To verify whether the model is correct, I'll just see the flux plot. So flux plot starts from here and it closes here. So the model is correct. Okay. So the model is correct. And the inductance, this is what we call it as aligned inductance, because the state aligned position, because the stator and rotor poles are in alignment. Right. So on the flux linkage, from the flux linkage, I can calculate the value of inductance. Okay. Psi is equal to L into I. Now, when I want to rotate this to unaligned position, so in SRM there are two positions. One is aligned position and unaligned position. I'll select this rotor. I'll say model rotate component. Okay, so here what I need to do is I'll rotate it to 30 degrees. Rotate it to 30. Okay, so 30 degrees is the unaligned position here, right? So with respect to A phase, say apply, sorry. Okay, I'll say close. Now I can simulate it. Now when you see the field, so it is like this. Okay, so this is what we call it as unaligned position. The flux lines at unaligned position. So from this only we will be able to calculate the value of aligned inductance, unaligned inductance. And from the energy and co-energy at aligned and unaligned inductance, we can calculate the value of torque. Okay, because torque can be calculated from this particular expression. T average is equal to aligned inductance minus unaligned co-energy at aligned. This is not inductance, sorry. Co-energy at aligned position minus co-energy at unaligned position to ns into nr by 4 pi. Now this is the first validation for the model that we have designed. So when you have designed the model and when you simulate it and when you calculate this value, this should match with our torque. Suppose if you have designed it for 10 Newton meters, so it should give 10 Newton meters. So that is the first check. Then only we will go for transient simulation. So calculate the co-energy at aligned position, calculate the co-energy at unaligned position, use this formula and calculate the value of average torque. Okay, so this I will also include it in the model. Okay, and I'll share this presentation with you so that you can check the value. You can design it and you can share the values. So this is how a basic static simulation will be done in SR machine. Okay, I'll also share this model. Okay,